Let's see that organic chemistry, the first chapter, alkyl halides and aryl halides. Okay, it's very easy, ma, and basics also important for organic chemistry. See, organic chemistry, we are feeling how much it is very easy, that much difficulty also. So main the thing is neat observation is very very important. Clean and neat observation is very very important, and then it becomes very easily. It becomes very easy, and we have to remember named reactions, preparation methods, and reagents and all. Along with that, IUPAC nomenclatures also we need to remember. Already, however, you are learned in first PUC only. See the let's see the first some introduction questions related to alkyl halides and aryl halides chapter. What is the IUPAC name of the given compound? See this CH3. Two CH3 groups are attached to CH. This is isopropyl group, like its common name. CH2 bond Br. Okay. See this, what is the correct IUPAC nomenclature we need to write. If you are observed that here the halogens also we are considered as a substance, and methyl group also we have to consider as a substance. Now the longest carbon chain is 1, 2, 3. 3 carbon atoms. However, you go either right to left or left to right, 3 carbon atoms present on the longest carbon chain having more substance. Here one methyl substance, one bromine substance, 2 substances are present. While you are giving the numbering from right to left, then that bromine position is 1 and methyl position is 2. Either you want to give the numbering from left to right side, then 1, 2, 3, there some of the positions 2 and 3 came. There some of the positions 1 plus 2 is equals to 3 and 2 plus 3 is equal to 5. So we have to follow the least sum rule. That's why this numbering is correct. Right side 2, left side numbering is correct. According to that, the position of bromine is 1, the position of methyl is 2, and 2 substances are present, 2 different substances. While writing its IUPAC name, we have to follow the alphabetical rule. Then its correct IUPAC name bromine B is letter coming first when compared to M. That's why its IUPAC name is 1-bromo, 2-methyl, 2-methyl. Root word is prop. All are single bonds only. Then ANE, propane. Okay, 1-bromo, 2-methyl propane. So the answer is third option is correct. Okay, students. Let's go for second question. The IUPAC name of allyl chlorides. See, we have to remember that classification of haloalkanes. So allyl chloride, what is the meaning for allyl chloride? Allyl chloride means the chlorine is attached to sp3 carbon. This sp3 carbon is attached to sp2 carbon. So like connectivity is present, such compounds are called allyl chlorides. So the allyl chlorides general representation, primary allyl chloride is CH2 double bond CH bond CH2 bond Cl. This is allyl chloride. Now its correct IUPAC nomenclature we need to write. Once you observe this structure, the double bond is present and the chlorine substance is present. So first functional group goes to more priority, then double bonds and then triple bonds. So according the double bond goes to more priority, or least number we need to give, then it is 1, 2 and 3. Now its IUPAC name is 3-chloro. The root word is prop, 1-ene or propane. Prop 1-ene. So the name is 3-chloro 1-propene or prop 1-ene or propene. Sometimes this no need to mention this one also, because the first portion no need to mention. So the answer is third option. 3-chloro propene or prop 1-ene or 3-chloro 1-propene. Okay, let's go for next. Third one, what is the correct IUPAC nomenclature of the given compound? Here bond line structures they gave. See this, let's see the bond line structures. Okay, like it is present the bond line structure. Okay, now is nothing but CH3 bond CH bond Br bond C. It has two substances CH3 and another CH3 is connected with CH2 bond CH3. This is the complete condensed formula, condensed representation. Now it's IUPAC nomenclature we need to write. Now if you are observed that here two substance, longest carbon chain, we need to choose 1, 2, 3, 4 and 5. This is the longest carbon chain. On the longest carbon chain has two methyl substance, one bromine substance is present. The numbering is bromine is came 2 and methyl positions are came 3 and 3. 2 plus 3 plus 3 is equal to 8. Okay, if you want to give the numbering from right to left, then 1, 2, 3. This is 3 came, this methyl substance, and bromine portion came 4. 3 plus 3 plus 4 is equal to 10. According to the least sum rule, we have to take from left to right side only. Then bromine, according to alphabetical rule, bromine name will comes first when compared to methyl. Then its correct IUPAC nomenclature is 2 bromo, 3 comma 3 dimethyl pentane, 2 bromo 3 comma 3 dimethyl pentane. So the answer is fourth option is correct. Okay students, okay, let's go for next question. Preparations of alkyl and aryl halides. See, it's very easy this question. See, the first one, ethyl chloride, CH3 bond CH2 bond OH is treated with PCl5, means OH group replaced. This OH group replacement reactions, then chloride ion will attack. Then the product is CH3 bond CH2 bond Cl plus POCl3 plus HCl. So chloroethane or 1-chloroethane or ethyl chloride. Its common name is ethyl chloride. So the answer is fourth option is correct. Okay, let's see the fifth one. Thionyl chloride is preferred for the preparation of chloro compounds from alcohols. Why? What is the main reason? From alcohols, let's see, alcohols ROH group reacts with thionyl chloride SOCl2. Thionyl chloride in the presence of pyridine. Pyridine is a base and also used as a solvent. Then produce RCl plus SO2 plus HCl. This sulfur dioxide is present in gaseous state and hydrochloric acid is also present in gaseous state. This process is known as Darjan's process. Darjan's process or Darjan's reaction. So this reaction is the best method for the preparation of alkyl chlorides because of byproducts are in gaseous state. If the byproducts are in gaseous state, means they will comes out from easily. They escape very easily because of their in gaseous state. Only we will get pure products. Only we are getting a pure products. So both the byproducts are in gaseous state. They can escape out, leaving the product in pure state. So the answer is first one. And this reaction is also very, very important. Okay. The only alkene which gives primary alkyl halides. Let's see that which gives only primary alkyl halides by the addition of hydrogen, hydrohalogenation, addition of hydrogen halides. See, the sixth one is addition of hydrogen halides. So unsymmetrical alkene is present. Unsymmetrical alkene is present. The addition reaction takes place according to Markovnikov rule. According to Markovnikov rule, and the halide ions are adding at less hydrogens containing double bonded carbon. Let's see that ethene CH2 double bond CH2. The addition of hydrogen halide HX. It is symmetrical alkene. Symmetrical alkene and simple alkene, that's why it produces only one product. Then the H plus ion is added at one carbon and the Cl minus is added at another carbon. Then the product is CH3 bond CH2X. The halogen is attached to the primary carbon, then it is called as primary alkyl halides. Primary alkyl halides. Okay, so the which one of the following produce only primary alkyl halides? That is one ethene. Let's see what about this remaining. C3H6 means propane. CH3 bond CH double bond CH2. The addition of hydrogen halides, it is a Markovnikov addition reaction, MA Markovnikov addition reaction. The H plus ions are added at more hydrogens containing double bonded carbon. Then X minus ions are added at less hydrogens containing double bonded carbon. The product is CH3 CHX bond CH3. Secondary alkyl halide will forms. Secondary alkyl halide. According, this is Markovnikov product. Same way C4H8 means we can write but1ene, but1ene or but2ene also. But1ene or but2ene, addition of hydrogen halides, always they produce secondary alkyl halides only. C5H10 means 5 carbons containing alkane. So pent1ene or pent2ene, that also produce secondary alkyl halides only. So among that, which produce only primary alkyl halides by the addition of hydrogen halides, that is ethene. Ethene to produce only always primary alkyl halide only. That is 1 chloro. If you are adding hydrogen chloride HCl, then 1 chloroethane. HBr do you want to add 1 bromo, ethane will produce. HI do you want to add 1 iodo, ethane will produce. It is always a primary alkyl halide only. So based on that halogen attached carbon atoms are primary carbon, then it is called primary alkyl halides. If it is attached to secondary carbon, it is called secondary alkyl halide. If it is attached to tertiary carbon, it is called tertiary alkyl halides. Okay. So the classification of alkyl halides also important for remembering, solving these kind of questions. Let's see the 7th question. It's very easy. Which reagent cannot replace by the OH group into Cl? See, from alcohols, this is the preparation methods of alkyl halides. Alkyl halides are alkyl chloride from alcohols. Okay, the first one, let's see. Alcohol ROH reacts with PCl5. PCl5 produce RCl plus POCl3 plus HCl. It's very clear. So the PCl5 can replace OH group into Cl. Now the second one is PCl3. ROH reacts with PCl3, phosphorus trichloride. Here 3 moles of alcohol is required, produce 3 moles of alkyl chloride plus H3PO3. Phosphorus acid is the byproduct. Next, the third one, ROH reacts with SO2Cl2, thionyl chloride, to produce RCl plus SO2 plus HCl. Just now only we are discussed. In the presence of pyridine is known as Darjan's process. Okay. Next reaction, let's see. The alcohols reacts with S2Cl2. No reaction. Okay, because S2Cl2 is nothing but S double bond S bond Cl is not a chlorinating agent. It does not produce alkyl chlorides. Okay, So the answer is third one. Okay, let's see the remaining questions. Which of the following has the lowest boiling point? Generally, we know very well in alkyl chlorides, boiling points order, boiling point is directly proportional to molecular weight. Okay, see in that boiling point order, alkyl fluorides, if R group is same, then alkyl fluorides are less than alkyl chlorides, and then alkyl bromides, and then alkyl iodides, because iodides are more molecular weight when compared to bromides and compared to chlorides and then fluorides when alkyl group is same. Now in the given compounds, let's see chloromethane and ethyl bromide, ethyl chloride, ethyl iodide they give. So the answer is the boiling point order is C2H5I. Ethyl iodide is more than ethyl bromide. C2H5Br, ethyl bromide, and then ethyl chloride, C2H5Cl, and then chloromethane or methyl chloride, because it is only one carbon is present, and here two carbons, and here also two carbons and two carbons, but iodide is present. That's why due to the presence of iodine and more molecular weight is present when compared to bromides, when compared to chlorides. But here methyl chloride is less molecular weight when compared to ethyl chloride. So that methyl chloride has the least boiling point or lowest boiling point is present. So the answer is first one. Okay, students, let's see the ninth question. Chloroethane is reacts with alcoholic potassium hydroxide. See, we know that chloroethane, CH3 bond CH2 bond Cl. If the chloroethane reacts with alcoholic KOH is very, very important. Alcoholic KOH acts as a base, undergoes elimination reaction. Elimination reaction means dehydrohalogenation minus loss of HCl, then the product is CH2 double bond CH2. Ethene is the product. In the same way that one chloroethane or chloroethane treated with aqueous KOH. Aqueous KOH acts as a nucleophile. The nucleophile is equal to OH minus ion. Then the product is CH3 bond CH2 bond OH. Ethyl alcohol will be the product. Now in this question, chloroethane or ethyl chloride treated with alcoholic KOH. Alcoholic KOH means elimination reaction. The product is C2H4. C2H4. Ethane is the product. Okay, let's see that 10th question. This is 10th question also. What is X in the following reaction? Chloroethane reacts with X. The product is ethyl chloride. Ethyl alcohol plus the byproduct is KCl. Then aqueous KOH. Aqueous KOH acts as a nucleophile. Then that alkyl halides convert into alcohols. Alkyl halides convert into alcohols. It is nucleophilic substitution reaction. Nucleophilic substitution reaction. It is primary alkyl halide. So that's why especially it is SN2 reaction. SN2 reaction, bimolecular nucleophilic substitution reaction. Okay, students, let's go for 11th question. 11th question is related to Hunts-Dicker reaction. This Hunts-Dicker reaction is useful to preparation of alkyl chlorides and alkyl bromides from silver salts of carboxylic acids. Hunts-Dicker reaction. This Hunts-Dicker reaction is nothing but silver salts of carboxylic acids or COOAG. Silver salts of carboxylic acids treated with halogen to produce alkyl chlorides plus CO2 plus AgX, where X is equal to chlorine or bromine. Okay, now here the reactivity order of silver salts of carboxylic acids. The reactivity order of RCOAG. If alkyl group, if alkyl group R group is N alkyl group. N alkyl is more reactive than isoalkyl. Isoalkyl and then neoalkyl groups. Neoalkyl groups. So according to that, N-alkyl group means in the given carboxylic acid is, the carboxylic acid is the straight chain, it is N-carboxylic acid. This is N-alkyl. It is CH3 twice CH is isoalkyl. Then it is also tertiary neoalkyl group. This is attached to that neoalkyl group. And this is also secondary alkyl group. So the straight alkyl groups are present. Then without branches, that carboxylic acids are more reactive. The carboxylic acids are more reactive and produce more amount of alkyl chlorides or alkyl bromides. Alkyl chlorides or alkyl bromides. Maximum yield is produced with 1, 2, 3, 4 butanoic acid. N-butanoic acid is possible. So answer is first one. Okay. Let's go for next question. 12th question is very important and easy also. See, that is the chemical properties of alkyl halides. 12th question. C2H5Cl chloroethane reacts with KCN, potassium cyanide. Here the potassium cyanide is ionic nature. Ionic nature, hence the products are alkyl cyanides. The product is alkyl cyanide. So the nucleophile is Cn minus. So the product is CH3 bond CH2 bond Cn. Okay, so the product is ethyl cyanide C2H5Cn. So the answer is Cn. Now in the same way, C2H5Cl reacts with AgCN. Silver cyanide has more covalent nature because Ag plus has pseudo inert gas electronic configuration is present. So the atoms are ions which are having pseudo inert gas configuration having more covalent nature. The atoms are ions which are having octant electronic configuration is present, then it has more ionic nature. Already in first PUC there we discussed Ag plus and Cn minus. So it has covalent nature. Covalent nature. So the nucleophile is Nc minus. Isocyanides. The product is alkyl isocyanides. So the alkyl isocyanides means here the product is C2H5Nc. C2H5Nc. Okay. Now in the 13th question, let's see the 13th question what they are asked. So ethyl chloride is heated with silver cyanide AgCN. See the different way they are asking, but however the main theme is we have to remember their chemical properties of alkyl halides preparation method. Then we can solve these kind of questions very easily. Okay, AgCN is present means the product is C2H5Nc. Isocyanides are the products. Okay, students, let's go for next question. Fourteenth question. Zinc copper couple in the presence of ethyl alcohol. Ethyl iodide is converted into ethyl iodide. CH3 bond CH2 bond I. Ethyl iodide in the presence of zinc copper couple and C2H5OH is a solvent. It is a reduction reaction. It produces nascent hydrogens. It produces nascent hydrogens. The product is CH3 bond CH3 ethane plus HI. Okay, it is reduction reaction. reduction of alkyl halides into alkanes. So the main important one reducing agent is zinc copper couple in the presence of ethyl alcohol solvent. In the same way, here instead of zinc copper couple, we can use lithium aluminum hydride, LaH, lithium aluminum hydride or sodium borohydride, NaBH4 also acts as a reducing agent. They reduces alkyl iodide into alkanes. Okay. Let's go for next question, 15th question. So the answer is ethane. Answer is ethane. 15th question, the dehydrohalogenation of ethyl chloride into dehydrohalogenation. CH3 bond CH2 bond Cl. Dehydrohalogenation means loss of HCl. C. Hydrogen atom. This hydrogen and this chlorine will be eliminated. Is called dehydrohalogenation. The product is CH2 double bond CH2. Then which of the following statement is correct? See, this all carbon having 4 single bonds, its hybridization is sp3. This hybridization also sp3. But carbon having double bond means its hybridization is sp2 and each carbon hybridization is sp2. So what happens? The hybridization is changes from sp3 carbons converted into sp2 carbon. So the fourth option is correct. Okay, let's go for next chemical properties of alkyl halides, that is SN1 and SN2 reaction, nucleophilic substitution reactions. We know very well nucleophilic substitution reactions are two types, that is unimolecular and bimolecular nucleophilic substitution reactions. In the SN1 reactions, order tertiary alkyl halides are more reactive than secondary alkyl halides and then primary alkyl halides. Okay, in the SN2 reactions, primary alkyl halides are more than secondary alkyl halides and then tertiary alkyl halide. Tertiary alkyl halide. It's very clear. Now ethyl chloride is converted into CH3 bond CH2 bond Cl is converted into ethyl alcohol. The reaction is belongs to C2H5OH plus Cl minus. See this alkyl halide, ethyl chloride is primary alkyl halide. So already I mentioned the primary alkyl halides are more suitable for SN2 mechanism. So this is SN2 reaction, bimolecular nucleophilic substitution reaction. So the answer is a second. Now let's see the 17th question is very important. Tosyl group, octyl, 1, 2, 3, 4, 5, 6, 7. Here hydrogen, it has one asymmetric carbon is present. Then this OH group is protected with tosyl group, PTSA, para-tosyl sulfonic acid. Then it is what is its configuration? So if asymmetric carbon is present, then they have RS configuration or DL, dextrorotatory compound or levorotatory compound. We have to identify its numbering. So according to this asymmetric carbon, 4 different groups are present. Now it is this is OH group is first oxygen attached. This chiral carbon or asymmetric carbon attached groups, 4 different groups. Oxygen is present. It is first. More priority goes to oxygen atom because atomic number is more. Next CH2 carbon and here carbon is there same. The next here carbon, here hydrogen atoms are there. Then this the total this alkyl group is goes to priority is second. Then this hydrogen is third. If you are arrange these positions, this is in anti-clockwise direction, but least priority group. The least priority group is on front side. Then the anti-clockwise direction. Anti-clockwise direction it is called as R nomenclature. This clockwise direction is called as S. when the least priority group is on front first, then this is R, this R configuration, this is on hydrolysis, hydrolysis taking place. See, solvated water means hydrolysis, hydrolysis, then the product is under SN1 mechanism, under SN1 mechanism, then what is the products? Racemic mixture will forms, racemic mixture. Racemic mixture is nothing but 1:1 ratio of R and S products. 1:1 ratio of R and S products means, let's see the structure. 1, 2, 3, 4, 5, 6, 7, 8. This second carbon having this OH group is front one OH group, another OH group. 1, 2, 3, 4, 5, 6, 7, 8. Another one OH group is on back side. This is if you observe this IUPAC representation, we have to identify that which is R configuration product, which is S configuration product. Here OH is group on front means hydrogen is on back side. Okay, here the hydrogen is on front side. Okay, let's see now. The OH group is goes to first, that remaining this is second, and this is third. Now it is in anti-clockwise, sorry, clockwise direction. Clockwise direction means R product, and least priority group is on fourth. Clockwise, then it is R octane 2-ol, octane 2-ol. Okay, and it is a 1:1 ratio. Racemic mixture means 50% of R and 50% S. Now it is OH is first, then it is second, it is third, then it is the direction is also in a clockwise direction, but least priority group or fourth group is on front, then we have to take reverse. We have to take reverse means it is S product. S product. Clockwise K means S product we need to take. Okay, then it is 50%, and this is also 50%. So the answer is R to octanol and S to octanol in 1:1 ratio. The first one is correct. Okay, student, this kind of questions are very, very important for JEE examination, especially JEE mains and advanced levels also they will ask. Okay, let's go for next question. The absolute configuration of the molecule during the changes. Let's see that 18th question. In SN1 mechanism, in SN1 racemic mixture will forms. Racemic mixture means 50% R plus 50% S product. In SN2 inversion reaction or inversion product will forms. Inversion configuration product. Inversion configuration, because the nucleophile attack on backside. Attack on a backside. So in the SN1 mechanism, sorry, in SN2 mechanism, if R, the reactant is R configuration, the product is S. If the reactant is S configuration, the product is R. R is nothing but dextrorotatory, D, and S is nothing but levorotatory, S, dextrorotatory. Inversion product will forms. So the absolute configuration of the molecule changes during the SN2 mechanism. Okay, let's go for next 19th question. For the nucleophilic substitution reactions, the rate is found to be, see, alkyl halides in SN1 mechanism, the rate, primary alkyl halides are more than secondary alkyl halides. Sorry, SN2 mechanism this is, and then tertiary alkyl halides, and in SN1 tertiary is more than secondary alkyl halides, and then primary alkyl halides. Okay, if alkyl group is same, then SN1, both SN1 and SN2 both order. Always alkyl iodides are more than alkyl bromides, and then alkyl chlorides, and then